Hello there. Today we are going to have a little talky video because I feel like talking, and what I was setting up for this video didn't really arrive at the mail. And no, it's not some Chinese stuff, so I have to make some substitutions. But I was thinking about making this video for some time. So here goes. And the topic of what I'm going to be talking about is power. Now, we all know that if you are seriously racing, you need a power meter, but not really many sources tell you why you want a power meter. They just tell you that you want some, and considering they are quite expensive, I can understand that they are going to be a rather difficult purchase to make. I haven't bought one yet. Knowing myself, I'm going to do it at some point, but I'm not racing, I'm just riding along and not really caring much, so I don't feel like I need a power meter. Although I'm sure that my curiosity, as I said before, is going to make me purchase one at some point. So we have a power meter, we have a device to measure something. So what are we measuring? In order to describe this to you, I need to start with the most abused term in the world, which is energy. So what is energy? Well, in spite of many interesting people will tell you, in physics, in the actual science, energy is an abstract term which can be explained best as ability to get stuff done. It's simply a measurement of how much change you can do or how much change has been done in something. For example, kinetic energy is the energy that tells you how much something has been done to accelerate a device or an object from velocity of something to velocity of something else. And if this object has a velocity of something, we know that if it hits a wall, it's going to deposit a proper amount of energy which you can measure. Likewise, the potential energy is the energy of height, which tells you that if something is in the elevation of something, and if it drops to the elevation of something else, it's going to deposit some sort of energy. But the concept itself is purely abstract. There's nothing measured. It's simply a term used to describe something that happens in the physical world. And as I said, in the best term, it is the amount of stuff can be done, the amount of stuff we can do. The unit of energy is, of course, a joule. And now we need to ask, what's the difference between, well, if I go to the mountain, I don't know, Mount Everest, obviously my potential energy is X. However, if I went there, I don't know, in 10 days, then I've been tired much more than if I went there in 40 days. That's a good question to have, and the reason is obviously, the answer is obviously, the other abstract physical term to describe this is power. Power, in strict physical terms, is the energy used on something in time. How fast you're using energy is power. The unit of energy is, of course, a joule. The measure of power is joule per second, and the unit of power is the very familiar watt. Alright, so why power has grown so much to be important in the end game when it comes to cycling and training? Well, if you are training, you want to do something called progressive overload. You want to measure some sort of property that tells you what are the results of your training. If you're, for example, doing a weightlifting, what you can do? You can measure the weight of something you have been lifting. You can measure how many repetitions you've done. Essentially, you can measure the potential energy as it changed, because that's what weightlifting is. You are lifting stuff, and the more you lift, the heavier, the harder your training was, and you can see that your stats went up from, I don't know, 100 kilograms to 200 kilograms of something, or 20 reps to 30 reps, what have you. You know you've done some work, you are progressing somewhere. How to get that in cycling? Well, the problem with cycling is that we don't have an easily measurable property. Because, for example, speed. Speed at 10 kilometers per hour doesn't seem like much of effort. You're just riding along, not really putting any effort in it. But 10 kilometers per hour on a 10% grade feels like you went to work, because 10% grade is hard. So we can't really use speed. So what about heart rate? Heart rate has been very popular because even now, well, when it started it was quite difficult, but now it's really cheap to get a heart rate monitor. You can even have one on your smartphone or some sort of a smartwatch or what have you. But heart rate is very good at measuring how hard your heart is working to get the blood flowing, but doesn't tell you how hard you're actually working, because it just measures this one property. And if you have a bad day, your heart rate can go up or down by 5 or 10 beats per minute, or if you just can't get it on, you just don't know whether you are really working hard or not. And of course, heart rate has a quite significant lag before it measures something sensible. So if you want to make some sort of interval training, well, what can you do? You just did the first 3 repetitions, now your heart rate is at 180, but you're resting, so are you really putting the power or not? Heart rate is not reliable. It is much better than speed, but it's not as reliable as power. Because power is measured with a device that's attached to your pedals or to your rear hub, which tells you directly how much effort you're actually pushing into your pedals. It takes away all the physiology of you, all the external factors, wind, incline, rolling resistance, how much pressure you've added to your tires. Everything just tells you one very easily measurable number, which is true regardless of all the environment around you. There is one extra thing about power meters, which is, I think, quite untapped, but with the proper software and coupled to a GPS will tell you much more than your effort. But that's going to require some scribbling. No video of mine appears to be complete without some scribbling, but in order to show you the untapped potential of a power meter, especially when it is coupled to a GPS, will require some explanation. In essence, it's not perfectly precise, but bear with me. The energy expenditure of your bicycle can be described as total energy is the kinetic energy plus the energy of drag. If your velocity doesn't change, this equals 0. You're not wasting anything to accelerate, which is one of the parts of the drag if we want to look at it that way. But we usually don't consider acceleration to be part of a drag. But there are 3 other forces which contribute to the drag, the force that stops you, and those are incline, how steep the road is which you are going to climb. Incline is perfectly measurable with the GPS, obviously Strava does it, it's trivial. And we all know that at some point the incline of the road is going to be the most noticeable force which we are battling, because, well, if you haven't tried something like 10% incline, you don't know what life is. Anyhow, aerodynamic drag is the drag of air which is pushed away by your body. In this case, also the drag of friction as the air flows around you. Aerodynamic drag is most important force to deal with when we're dealing with speeds, well, significant, 20-25 kilometers per hour or faster. And at a certain point, something about 45-50 kilometers per hour, if you're riding on a flat, you're essentially using most of your effort battling this. This is why the minor benefits crowd are so wild about aerodynamics, because aerodynamics at high speed is king. In order to show you the magnitude, the fastest bike in the world, which is some sort of a recumbent, is optimizing aerodynamic drag, and they are able to reach speeds upwards of 130 kilometers per hour using human muscles. You and me, we are lucky if we push 40. Anyhow, the third force to deal with is the rolling resistance, which is an aggregate of all the friction of all the mechanical parts in your bicycles, coupled with friction of the tires through the road. Now, what's the beauty of the GPS? if we are accelerating, GPS can measure this, so we can take this off our table. Now we have three things to ponder about. Now, incline is perfectly measurable by a GPS, so we can take this off. Now, we have the aggregate of aerodynamic drag and rolling resistance to hold on or know what are their values. But at very low speeds, aerodynamic drag is negligible, which we can ignore it, which means that if we measure the power at the pedal at a speed of approximately 5 kilometers per hour, then we are only measuring rolling resistance of your bicycle. Because rolling resistance is rising linearly with speed, we can pretty much say that if your rolling resistance is like 10 somethings at a speed of 5 kilometers per hour, whatever, 10 somethings at 5 kilometers per hour, then it's going to be 20 at 10 kilometers per hour. It's going to be 40 at 20 kilometers per hour, and so on and so forth. Which means that we can calculate this by calibrating our mechanism or our power meter, our GPS unit, and special software by measuring the power at the pedal at a very low speed, and then estimate this at higher speeds, which means that using a power meter and a bit of software we can measure our aerodynamic drag, or at least estimate it with a very high precision. I don't think any software does this, but think about this. You don't need a wind tunnel, and you can measure this. You can measure this regardless of a bicycle you have. Simply by knowing the power input, having the power meter and the software which would know how to do this, take the rolling resistance into account, take out incline, take out acceleration, because those are perfectly measurable by taking GPS measures, and you have your own wind tunnel. It's not going to be perfectly precise, but it's going to be precise enough to tell you if you're gaining or losing something. Now that was pretty cool, wasn't it? Now don't go just buying your power meter just yet, because power meters are most useful to people who actually train, make notes and compare the results. Otherwise they just tell you the number that's very close to what a heart rate monitor will tell you. Or at least they tell you the information that heart rate monitor will also tell you, just with a little lag, because it will tell you your effort, and you can always compare how you feel about something with the indication of your heart rate monitor or your power meter. But I expect that now it's a problem because power meters are quite expensive, but in 5 to 10 years we're probably going to see some budget units. Frankly, if I was myself, and I am, once I get a power meter that's, I don't know, $100 or so, it's going to be 5% precise. I'm going to get one just of sheer curiosity because, well, I don't train, but I'm curious. But for now, it's a hard sell for me because I don't train, as you can imagine. And now I'm going to start rambling for no reason whatsoever, so I think this is just about everything I have to say about this. What you have to take from this video is that power is so useful because it detaches everything physiological. It gives you one number that tells you how hard you're working. And if you're training, you want to have some number to track to tell you how hard you're working. And with that in mind, thank you for your undivided attention. I hope this wasn't 25 minutes long. Like this video if you haven't already, subscribe to the channel because I ramble like this every once in a while and you might enjoy it. And I hope to see you in the next video.